Okay, so question 64 here, you've got your function f defined as 3x plus k, alright? And the domain is 1 infinity, and they ask you then in part A to write down the range of f in terms of k, right? Because this k is a constant. So if we put 1 into the function, you'd have 3 times 1 plus k, which is just 3 plus k, right? K is a constant, we don't know what it is, but that's what you end up with. Put infinity in, you have 3 times infinity plus k. Well, 3 times infinity is infinity. Adding k is, because a constant doesn't make any difference. So you get your range then, 3 plus k included, and then infinity then. Okay, so that's your range. So then it goes on, you've got the function g of x, and it's written like that, x squared minus 6 for this domain. It says then, part B, find the least value of k so that the function g of f can be formed. Okay, so for g of f to exist, right, you've got to understand how composite function works. Okay, for g of f to exist, f goes into g, so remember that, f goes into g. So you work out, essentially, this is what you're doing, isn't it? You are putting f into g. If you put an f into g, all of the output of f is going into g. Think of it that way, because f's going into g. All of the output, all of the things that come out of f are going into g. In other words, the range of f is going into g. So the range of f, right, then going into g. So that means the range of f must be contained in the domain of g. Okay, right? Okay, that's what is important here, because all of the output, all of the stuff you get from f goes into g, right? Then the range then is this output of f goes into g, so the range of f must be contained in the domain of g. In other words, it must be able to go into this into the acceptable domain of g, which is defined here. Okay, so we could say the range of f, which is 3 plus k infinity, must be contained, okay, in the domain of g. So it's got to fit in there because it's going into g, of course. Okay, so we've got to have that. Okay, so in other words, you can't have this to be minus 8, right, or minus 100, because it won't fit in there. Okay, this has to be minus 2, right? That's the lowest it has to be. Okay, in other words, 3 plus k has to be greater than minus 2. That's what I'm trying to say there. Okay, if it was less than minus 2, if it was minus 10, it's no good because it won't be contained in there. It's got to be greater than minus 2. So therefore, k, take the 3 over, it's minus 3. K has got to be greater than minus 5. Okay, and it says then find the least value of k so that g of f can be formed. Well, k has got to be a constant, so you could just say, look, k has got to be greater than minus 5, and that's answer the question. Okay. So then, write down an expression in terms of k for g f of x. Okay, that's part C now, g f of x you want. Okay, now g f of x means you put f of x into g. Okay, so f of x is 3x plus k, right? So you put f of x into g, alright? So x squared minus 6, this will become 3x plus k all squared minus 6. Okay, so you can leave it like that, so that's your g f of x. And then it says part 2 then, given that g f of 2 equals 3, find the value of k, right? So we've got this situation set up here so that g f of 2, okay, equals 3. So basically we need to set x to equal 2, right? And put the whole thing then equal to 3. Okay, so then you get, then this will become 6 plus k all squared, take away 6 is 3. Take that minus 6 over, so it becomes plus 6, you end up with 9. Okay, Then take the square over to square root, so 6 plus k will be the square root, but plus or minus then square root of 9 is 3. So you get then 6 plus k equals 3, or 6 plus k equals minus 3. Okay, that means then k will equal minus 3, or k will equal minus 9. Okay, however, go back to what we defined originally, k had to be greater than minus 5. Okay, so this is impossible. Okay, we just say outside outside of the range for k, right? Outside of k basically greater than minus 5. So this is our acceptable answer. So k equals minus 3 is our solution.